This lesson is about multiplying polynomials, and so we'll still have to use some of the methods that we've previously used with adding and subtracting polynomials. But when we multiply polynomials, we multiply the coefficients together. So in this first case, we would say 2 times 5, which would be 10. And then we multiply the variables together, we actually add their exponents, because x cubed means that there are 3 x's. X to the 6 means there are 6 x's, so a total of 9 x's is what I would have, so I would say that that would be x to the 9th. And so this would be a monomial times a monomial, which still is a monomial, talking about the amount of terms. The coefficient of this term would be negative 1 times 10, which would be negative 10. You add the a exponents together, so you would have 2 plus 1, which would be 3. You add the b exponents together, so 3 plus 2, which would give you 5. And you would add the c exponents together, 1 plus 12 would give 13. And that would be your final answer. If you're multiplying a monomial times a binomial, you use your distributive properties. So 4x times 3x would actually give you 12x squared. Again, adding those exponents. 4 times negative 2 would give you negative 8, and you would still have an x beside that. And of course, if you could add those terms, if they were like terms, then you would actually add them, incorporating the previous lesson. This example is a monomial times a trinomial. In using the distributive property, we would say negative 1 times 4, which would give us negative 4. A, 2 plus 3 would give us 5. And then we would also have a, b. And we have to distribute, so we'd say negative 1 times negative 2 is positive 2. A, 2 plus 1 gives you a to the 3rd power, and b, 1 plus 1, which would give 2. Negative times a positive would be a negative. I would just write a squared first. It doesn't matter. B times b squared is going to be b cubed. And I would look and see, well, could I add any terms together? In this case, I can't. They would have to be the same exact variable with the same exact exponent. So that would be the final answer. Now, to multiply binomials, we use what we call the FOIL method, which means first, outer, inner, and last. So when we're looking at an example such as x plus 2, which is a binomial, times 3x plus 1, which is a binomial, these two terms would be considered to be our first terms. So we would say x times 3x, which would give us 3x squared. Again, when we multiply those variables, we add the exponents. These are considered to be our outer terms. So we have x plus 1, which is positive x. Our inner terms would be the 2 and the 3x. So 2 times 3x would give us 6x. Again, multiplying those coefficients together, and that variable just comes along with it. Our last term would be 2 times 1, which would be positive 2. And that would be our FOIL method, first, outer, inner, last. And it really doesn't matter which order this is multiplied in. This is just typically how we view multiplying binomials in mathematics. Now, again, we need to look and see, are there any terms that are alike? And in this case, we do. We have an x term and or 1x and a 6x, and the x is what makes them the same. You add their coefficients, 1 plus 6, which would give us 7. And then just bring down the 3x squared, and then the positive 12. So we only added these two terms together. This is descending order, a degree of 2, a degree of 1, degree of 0, but the highest degree would be 2. When we use our FOIL method for this next example with these two binomials, we would say x times 2x is 2x squared, again adding those exponents. X times negative 5 is negative 5x. Inside 3 times 2x is positive 6x. And last term is 3 times negative 5, sign and all, will be negative 15. We have like terms here and here. So we have an x term, negative 5 plus 6 is positive 1. I'm just going to leave it as a blank just because of the fact that it's understood positive 1. And then you have negative 15. Will be our final solution. The next example is multiplying a binomial times a trinomial. So I would take the 4x squared and I would multiply, so distribute it. So 4x squared times x squared would actually be 4x to the 4th power, because again you're adding those exponents. 4 times negative 2 is negative 8. X squared times x is x cubed. 4x squared times positive 1 is just positive 4x squared. So we've distributed the 4x squared to all three terms. Now we're going to distribute positive 3 to all three terms. So 3 times x squared is 3x squared. 3 times negative 2x is negative 6x. 3 times positive 1 is positive 3. Again, we need to look for combining like terms. My highest degree is the degree of 4, and there's nothing I can add that to. There's nothing I can add the degree of 3 to. I have a degree of 2 here and here, which keeps it as a degree of 2. You add their coefficients. 4 plus 3 is positive 7. Then I have a negative 6x, and I have a positive 3, and I can't add anything else together. And that would be my final solution.